have these written down so we can check them and go through them. Remember that you should be using your point slope formula for these, for either or. Disregard number 3. That will make more sense. Actually, I don't think we're going to get to that. That was really for one of my other classes. But number 2, they gave us a point, they gave us a slope, so we can put that in our point slope. Multiply. Here, I changed this to a plus because it was negative, but if you put minus a negative and then change it to a plus, that would also work. Get rid of the 3 on the side, so y equals 1/2 x plus 5. Remember that the way Khan Academy does it is using your slope-intercept form, and that method works, but you do still need to know how to use this method for the test. Questions on number 2? Number 4, you needed to remember your toy box. Vertical lines are x equals equations. And because this is an x equals, we look at what number x is, and it's 4, and that would be our equation. I believe one of the Khan Academies maybe did something like that, but I might be mistaken. Do we have questions on either of those 2? So far we have talked about how to write equations from graphs and how to write equations from when given slope at a point or when given 2 points. Now we're going to kind of switch gears. So I'm going to pass out our notes for today using a ruler. So you can go ahead and do that. There are colored pencils, that way you can distinguish which are which. You may need to sharpen some of them. So you're going to graph these 2 points, and you're going to graph a line through them. And then you're going to do the same thing for brown and green. I would say use your rulers to make them as accurate as possible. Draw your 2 points, draw a line through those 2 points. As close to these as possible. Mine could be a little off because I did them eye leveling at them without a ruler. So mine may not be as straight as it should be, but on the next page, it gives us the equation of line A, line B, and line C. Those are the lines that were already given. If you want to color them or outline them, that way you know which one is which, you could definitely do that, but that's not a necessity. The next box asks you to use the points given, so they gave us a little box of points to write the equation of each line. However, we could also, because we have a graph, count the slope and y-intercept from the actual graph itself, and then just write the equation. I wanted to do this part together to make sure we all had the same equations when we go on to the next part. So, do one of the following. We need to either count our slope from the graph, or use our points that we were given, and find the slope-intercept forms of these 3 lines, the ones we just drew, the red, the brown, and the green. So I'm going to, because my graph may not be that accurate, I'm going to count the slope from this. If any point gave me a y-intercept, I'll use that. But other than that, I'll use my point slope to find my slope-intercept. So for my red line, I'm going to rewrite the points that were given. -3, 2, and 0, 4. This is on the next page. Now if I look at the 2 points I plotted, I can count the slope of that. What is that slope? And I can make this bigger if not. You can count it on yours. It should be the same. Should be positive. If you're going, should be the other way. 2, 3 should be your slope. This line gave you your y-intercept, so there's no real work for you to do. So we can say the equation of this line would be y equals 2/3 x plus 4. And we could go back to our line and double check and make sure, if we want to fix our line a little bit, make sure it's very accurate. I could go back and count all my slope points, go up 2 to the right 3, as many times as possible. And down to left 3 as many times as possible. That actually was pretty good.
Wait.
Yes.
I'm confused with the cycle after the 2/3. M equals 2 + b.
Say that one more time.
The b with the arrow. The cycle after the 2/3.
After the 2/3 x.
So m equals 2 + b, right?
Plus b, which is 4. So y equals mx plus b. This is your m, and this is your b. The 4 that they gave you is your b. Your brown line, we could also count the slope of that. This one did not give you your y-intercept, so we'll have to find it. So I'm going to write those 2 points down. We're going to look at our slope, and then we'll do the work. I'll make this bigger so we can see the work for the brown line. So the 2 points for the brown lines were -5, -1. And 5, -5. So then count your slope on your graph and tell me what that would be. So, -2/5. I feel like that's accurate. So -4/10, but that simplifies to -2/5. And actually, you could do the work for this algebraically, or you could use your graph. Since you know that your slope is -2/5, I could, instead of doing my point slope, I could go back to my graph and count up to left side as many times as possible. And I should end up at my y-intercept instead of having to do that work. And then I could keep doing that up 2, back 5, 1, 2, 1, 2, 3, 4, 5. That one was a little off. 1, 2, 1, 2, 3, 4, 5. So if I keep counting backwards up to the left 5, I will get that I have a y-intercept at -3. So that's less work if we do it that way. If you did use point slope to find your y-intercept, that's also fine. But now we can say this equation is y equals -2/5x minus 3. Okay. And then we're going to do the same thing for the green line. The green line's points were 1, 1 and 2, -2. And we can count the slope from our graph. What was that slope? -3. If I start at this point and I go down 3 to the right one, that would be my slope. And again, you can either count from your graph or use your point slope formula to find your y-intercept. I'm going to count from my graph. So if my slope is -3, I'm going to keep going back to go up 3 to the left one until I get my y-intercept. And just make sure my line follows that same slope by putting my slope points everywhere. 1, 2, 3. 1, 2, 3. If I go down 3 into the right one, same thing. So my y-intercept should be the same y-intercept my red line was, which was 4. So we can say this equation is y equals -3x plus 4. So I'm going to give you a little bit of this information, and then the next page I'm going to let you guys work together and try and figure this out. Do we know anything about parallel lines? Aubrey?
So they have the same slope, but a different y-intercept.
Okay. If you didn't know that specifically, graphically, how would you know two lines are parallel? Davina? They don't ever touch or intersect. So like looking at my lines, let's fix this a little bit. If I were to say, which two lines look like they're going in the same direction but don't touch, which two lines would you say? And there are different answers here. You know what you say? Green and C. Those look like they're going in the same direction but are never going to touch. Javier, what were you going to say?
That one and the one.
So A and B. And then Mariana, what would be the last pair? What would be the last pair of lines that go in the same direction but don't look like they're going to touch? We got those two? A and B. So when we think about parallel lines, think about that they go in the same direction, they look like they're going in the same direction, but they're never going to actually touch each other. So the answers to that next page, the one that's parallel to line A would be the brown line. and it wants you to write the two equations. So you would write the equation of line A and the equation of the red line. The equations for A, B, and C are at the top. So y equals negative 2 over 5x plus 1. Yep. And then the brown line, put right underneath that. Y equals negative 2 over 5x minus 3. For line B, we said that the red line was parallel to it. So we would write red line and write those two equations. B was y equals 2/3 x minus 2. And the red that we just found was 2/3 x plus 4. Leaving the last one to be green. For C, that was y equals negative 3x minus 2. And your green was y equals negative 3x plus 4. So this next part you're going to do on your own, / you can use the people at your table for any questions you have. Before I let you do that, do we have any questions for me on how we found any of this so far? So the next page, go ahead and start answering those questions. Let me know if something doesn't make sense or you need more clarification. Ask the people at your table as well, because they could have a similar question. And then we'll go through those answers here in about 10 or so minutes. Some of these answers. For number 4, what did we notice about the slopes? They're the same. In each pair, they're the same. So if you wrote something specific about like what numbers they were, or like they were both negative, you were like on the right track. Or if you said they're parallel, you wouldn't really know that unless you looked at the graph. But if you're talking specifically about the slopes, they're usually the same. Okay? What about the y-intercepts? They're different. Is that what you're going to say,
Yeah.
Yeah. So a general statement, you can kind of combine those two things. Parallel lines, or 4 parallel lines, the slopes. Is your laptop okay? The slopes have to be the same, but the y-intercepts have to be different. That could be your general statement or something similar to that. like you have the same slope, let's pick a number, 3. So y equals 3x plus 1 and y equals 3x minus 1. They could be the same number, but one's positive, one's minus, or one's negative. They would still be different y-intercepts, and that would still work. Or they could be completely different, like y equals 3x plus 1 and y equals 3x plus 5. So based on this general statement, from this number 1, are y equals 3x plus 7 and y equals 3x minus 8 parallel to each other? Yes. They have the same slope, but they have different y-intercepts. What about number 2? Are these parallel to each other?
No.
No. These do not have the same slopes. They have the same numbers, but they're switched. So those are not parallel. This is a different one that's not up here. But what if I said these two? They'd be the exact same line. So they would not be parallel. They would be the same line. Is how you would answer that. So no. Okay. Someone give me one example they use for a parallel line for y equals 2x minus 3. Avina?
Y equals, oh. Y equals
Okay. Aubrey?
Y equals 9 plus 2.
And I need one more. Someone give me one more. Aubrey, go ahead.
Y equals 2x plus 2.
You have that one?
Y equals 2x minus 5.
Sure. So I need 3 different people to give me 3 lines that are not parallel to y equals 5x minus 2. Saeed and then Araya. Okay, Araya.
I'm not doing it. Y equals 7x plus 30.
And one more.
Y equals 59 over 200.
Why? Why?
For what reason? Because. Is
For
it
what
math
reason
of it,
did you
or-
do that?
Oh yeah, minus 2.
Why did you minus 2?
Because.
I just made you like, because she can.
Because like,
I mean,
like
it's
anything
not
that's not 5x. It's not
True.
that
Wrong.
That is,
And
It's
actually,
not wrong.
It's not why.
Aubrey.
May I learn to math?
Why?
Yes. Alright. How many of you have already done the graphs for these? That means some of you still need to do the graphs for the perpendicular ones, so go ahead and take a second and do that. Alright, and if some of you were copying some of that down, I'm going to go to the next page in a second. So your line should look something like this. Represent something that looks like this. My blue line is off of it. And then as you were finding your slope, finding your y-intercept, your blue line's equation was y equals negative 3x plus 2. Your purple was y equals 1/3 x plus 7. And your orange was y equals 5 over 2x minus 10. So I did the exact same thing we did before, found the slope and the y-intercept from the graph, except for the blue line, it gave you your y-intercept. Okay. From a graph perspective, does anyone know how 2 lines would be perpendicular? Okay, no. Oh. They do cross, but There's something specific about the way they cross. Say it again. What do you mean by that?
Lines are like electrical,
Somewhat.
Look the same.
What about them is the same?
Like, interaction.
Not quite.
It's called perfect 90-degree angles. And you keep the little corner thingies.
Eric, what were you gonna say? Okay, so if we look at these lines, yes, they have to cross. I went back too far. But they can't just cross and make like whatever. They have to cross and make like a T. Not an X, but a T. So when you look at it, and you're comparing the colored ones to the black ones, A and this purple line make an X. They don't make a T. Purple doesn't even cross B, so we can ignore that. But as I look at purple and C, they make this perfect T right here. So C and purple would be perpendicular. What other two pairs of lines do you think are perpendicular? Sabina. The orange line in A. So they make that perfect T right there. Or you could make an L, either or. But they do that here. It's hard to see with all of the lines, but they do make that T when they cross. So A and the orange would both be perpendicular. Which leaves the blue line and B. And if we look at where they cross, they're making that T right here. Again, it's hard to see when all of the lines cross each other. But you can write down those two, or those three. What did we say? A and orange? So, negative 2x. And the orange was 1 equals 5 over 2x. B and the blue. Two-thirds x minus 2. I think these are the exact same lines. You're going to do the same thing. Answer the questions on the next page. Ask me if you get stuck. Use each other at your table. Compare your answers. And then the very last thing we'll do is go over that before we end class today. About the slopes.
They're exact. They were reversed from each other, like and side.
Okay, so you said the sign they had was different,
So
the
like
opposite.
the one was a positive, the other one was a negative,
Okay.
and then the two numbers to the fraction were
Okay. And then you guys were kind of saying the same thing. Say what you said again.
Oh, there's a reciprocal.
Okay.
There's a positive.
There's an even more specific way to say that, and we're going to do that in 1 second, Mia.
The exact opposite.
They're inverses, they're exact opposites. All of those things are true. The word for that are, I'll put what you guys put, and then I'll actually do what it is. Opposites, inverses, those kind of mean the same thing. Reciprocals, you guys have all of those things. Perpendicular slopes have negative reciprocals, is really how we describe them. Because one is positive, one is negative, and they take the number and they flip it. And then what about the y-intercepts? It doesn't matter. They can be the same, they can be different, it doesn't matter.
Either way, the most important thing is the slope when it comes to determining if two are perpendicular.
Correct. So putting those two together, for perpendicular lines, the slopes have to be negative reciprocals, and the y-intercept doesn't matter. Is really what you could put. So based on that, for number 1, are 3x plus 7 and 3x minus 8 perpendicular to each other? No, what would those two be? They'd be parallel. That's actually the same example we just saw. Are these two perpendicular to each other?
Yes.
Yes. One is positive, one is negative. They took the numbers and they put them. The y-intercept doesn't matter. So those would be perpendicular. What if I had something like this? Why? Because one of them isn't negative. They would be intersecting, but they would not be perpendicular. They wouldn't be parallel either. Right? Give me 3 lines that would be perpendicular to y equals 2x minus 3. Go ahead.
Y equals negative 1/2 x plus 423 million.
Wait, pause. 1/2x plus. Say that number again.
423,275,700.
That's so specific.
You lost. Next 3. 2,
5,
275,
733.
733.
That's great.
Point
Oh my god. Point what?
Oh my god.
Point what?
3141596.
That sounds like a social security number.
Yeah, they tied to that. Okay. That would be perpendicular though, because the y-intercept doesn't matter. Give me another one. Are all of your answers like that?
Just kidding.
Just
All of that and
go ahead.
Y equals 1 equals 1.5 x plus 926,270,000 squared pi.
I missed all of the numbers you said.
Just 925.
It's a Monday.
470,291 square pi.
I like the creativity.
Yeah, you can't beat my script.
One more.
Normal number.
Okay. Oh my gosh. No, come on.
Thank you.
Go ahead.
Y equals x plus 6.
Awesome. Wow. In comparison.
6x.
Okay. Really quickly, give me two that are not perpendicular.
Anything with y equaling 5x, just anything. Pick your y and do that. It doesn't matter.
Just literally just
3,
anything.
4, 9, 2, 9, 3, 9, 4.
More like this.
I don't remember how to read it.
Well, there, that's normal.
Okay, watch this.
Okay.
Quickly.
I wish you that in trillions. I'm happy.
You're done.
Counter argument.
Millions don't even exist.
Millions.
It's gonna be a Monday night.
I am trillions right now.
No, you're not.